Are we on? Hello, everybody. Here we go again on the anti-relativity discussions. This is number 4. Einstein's relativity kept changing without explicitly being emitted by the mainstream. Hopefully you can hear me all right. Is that right, Franklin? Can you hear me?
Yep.
Great. Okay, all systems go. So if you put up the slides, please. Yeah, excellent. So this is anti-relativity 4, as I've just said. Let's get into the introductions on this. Next slide. So the video we will be looking at is called The Real Reason You Don't Understand Relativity. And hopefully you can read this because it's too small for me. If you think relativity is confusing, this is what the website says. That's given the video. It's by a person who calls himself Dialectic. Well, it's not you. Even the experts can't seem to agree on its meaning and often get basic facts about the formalism completely wrong. Here we critique, and that's in the video I'm going to present you, one such renowned professional who, in claiming to be clarifying the standardized theory of relativity, turns out to actually be promoting a misguided personal interpretation. And that person will be Sabine. She considers herself an expert in relativity and she has a PhD in physics. What is the expert's confusion? That's Sabine exactly, and why are such misconceptions so prevalent amongst the physics community? ? And so it then, talks about gaslighters and so forth who want to confuse your inability to understand relativity stems from own deficient reasoning. So it's these experts, they don't really properly understand what they're talking about either. Next slide. So the video itself raises some interesting points. Many of the statements from relativity are vague as to what is supposed to be meant, and video also points out the mathematical formalism in quantum mechanics is recognized by mainstream as having lots of different interpretations. So surely the mathematical formalism of relativity should have many different interpretations as well. I.e., if quantum mechanics has lots of interpretations, why doesn't relativity be recognized as having lots of interpretations as well? But unfortunately, everyone in the mainstream acts as if relativity has only one interpretation, and the person gives their interpretation pretending it is the only interpretation. Einstein gave a series of papers on relativity and kept change in his mind. So he never gave a solid interpretation himself. And then the video gets on to take as an example Sabine's interpretation of relativity, a physicist from the mainstream who has a few dissenting views with the mainstream. Next slide, please. So this is Sabine, who's being criticized by the video I'm presenting, and she's also critical of the mainstream to some extent. So really, we're just criticizing what she's saying about relativity and maybe agreeing on other things she's saying about physics. And so that's the end. That's just my little presentation. Now let's get on to the video. Hold on a minute while I change things around. Remove the studio. Oh, there we go. Today, present, share screen. There you go. The real reason you don't understand relativity. So here we go. Can you see that? I hope you can. Let me start the video.
Almost every approach to teaching relativity begins the same. You get a set of pseudo-physical sound statements. Time and space are relative.
Sorry. Okay. I should turn the sound off my other thing. Hold on a moment. Hopefully you can hear me right. Is that right, Franklin? Can you hear me? Delete. Yep. Oh, fine. So back to this again. Start again after full start. Cheers.
You can make it full screen.
Yeah, oh, okay, I'll try that as well. Yeah, full screen.
Almost every approach to teaching relativity begins the same.
There we go.
You get a set of pseudo-mystical sounding statements. Time and space are relative. The universe has a speed limit. No entity exhibit. Then you are told certain empirical experiments prove the math, and the math in turn proves the philosophy. But does a mathematical formalism ever necessarily necessitate a single interpretation? Certainly, this isn't the case with quantum mechanics, which sports a rich diversity of viable and competing philosophies. Of course, this might lead you to question, are there other interpretations of relativity out there? And if so, should we be teaching them? This is Dialect with the real reason you don't understand relativity. Last year, we successfully debunked a major myth of general relativity, which went along the lines of time dilation causes gravity. At the time, this idea appeared to us to be so ludicrously in contradiction with the basic tenets of relativity that we assumed it had to be a product solely of the YouTube sphere. But after publishing our video, we discovered to our surprise that the misconception extended far beyond YouTube, appearing in textbooks and even quoted by renowned physicists. This, of course, got us wondering, how could such brilliant people get their own theory so incredibly wrong? Well, the answer is because relativity, very much like quantum mechanics, is extremely confusing, and it's doubtful anyone truly understands it. Of course, with quantum mechanics, this fact, being openly acknowledged, has led to a rich and intriguing field of diversified interpretations. But in relativity, everyone carries on just as if they were all teaching one and the same interpretation, the one they call Einstein's. The problem is, few people are acquainted with Einstein's actual work and don't know that Einstein never really had a solid interpretation of relativity. Most people teaching relativity are unaware, for instance, that Einstein himself didn't believe in the conventional solution to the twin paradox, or in absolute acceleration, that he didn't believe in black holes, that he didn't believe in cross terms of the line element, that he didn't believe in the geometrization of gravity, or, most shockingly, that he did believe in the ether, or at least that he reversed his stance on it in 1920, when before an audience at the University of Leiden, he declared that general relativity necessitates space be endowed with certain physical qualities, and since the special theory of relativity does not compel us to deny ether, that therefore there exists an ether. Indeed, a number of major shifts in Einstein's interpretation of relativity can be traced throughout his lifetime. And he died never really having made up his mind about what the theory actually meant. In his wake, he left an immense philosophical vacuum, which modern physicists are still trying to fill in with their own ideas today. The result is an extraordinary and inordinate confusion, which you can see clearly on display in the wide number of personal interpretations that professionals give to their explanations. Such differing interpretations can be found in any number of YouTube videos. but today we're going to pick on one in particular. Sabine Hassenfelder's Why You Misunderstand Relativity. Now, we enjoy Sabine's channel, and we were, in fact, greatly appreciative of this video on the whole, since it corroborated our own video from a few months earlier about how you're accelerating up at the surface of the Earth. But on the flip side, this video also brings several contradictory statements into immediate proximity to one another, and in doing so, demonstrates just why relativity is so badly in need of better interpretations. No, this isn't an attack personally on Sabine in any way, and she has plenty of great content. But we do feel that her arguments in this video are representative of the confusion of the greater physics community as a whole. Now, the video gets off to a strong start, with Sabine emphasizing the formalism of relativity over its philosophy, and explaining that our confusion about relativity stems from the simple fact that we're treating time dilation too literally. That is, taking it to be something physically real when it's rather just an artifact of how we choose to do measurements and draw up coordinates.
The time that passes between two events is not the time on the coordinate axis. That's just a label. It's convention. It has no physical meaning. This is what people often call time dilation. I'd call this pseudo-time dilation because it's a meaningless comparison. Why would you care about the coordinate time? It's just a label. It has no physical meaning for Bob.
All of this is great, and it seems very in keeping with Einstein's original 1905 special relativity paper, wherein you won't find too many grand statements about the nature of space and time itself, but rather just a simple demonstration of how adopting light as a basis for our spatiotemporal measurements conveniently reproduces the already well-known at the time Lorentz transformations. But a few minutes later into the video, while Sabine is discussing the twin paradox, she gives us this statement.
Where he travels. This is the real time dilation. It comes from the acceleration. This is the real time dilation. The real time dilation.
The real time dilation.
Like, what? First, she was telling us we were confused about relativity because we were treating time dilation too literally. And now she's saying time dilation is something literal. And to understand the theory, you need to accept a fact that only minutes earlier was stated to be the source of your confusion. Again, like, what? Let's slow down for a second. More precisely, Sabine's saying here that time dilation is only real for the special case of acceleration. But as she implies in the beginning, it's the idea of any sort of time dilation being real that confuses people. Indeed, by saying that time dilation is only real for acceleration, she thinks she's resolving the source of our confusion. But she's not. She's merely transferring it from the case of velocity to the case of acceleration. Secondly, she neglects to mention that observers who aren't accelerating will not perceive the same manner of time dilation as those who are. In a uniform gravitational field, for instance, observers who are stationary within the field, i.e. those who are accelerating, will see clocks at different positions tick at different rates. But an observer free-falling in that field will see those same clocks all ticking at the same rates, no matter what their location. Thus, any observer not sharing in the acceleration won't be able to agree on the time dilation of the clocks. So, by no means can we claim accelerated time dilation to be any more or less real than velocity-based time dilation. They both are coordinate observer-dependent phenomena.
Right.
Now, Sabine does point out that a more meaningful comparison of time ought to happen when observers are rejoined at the same place to compare clocks, which is why she brings up the twin paradox. But she gets something very wrong when she says that the real time dilation comes from acceleration. The asymmetry of the paradox certainly comes from acceleration. But to Alice, Bob's velocity or kinematical time dilation is very real and the cause of his slowed aging. And to Bob, Alice's kinematical time dilation is likewise also very real. But now in his case, there's an additional accelerative time contraction which he has to add atop the kinematical dilation. Thus, it's actually the kinematical and accelerative time dilations/contractions taken together that describe the real proper time. If you leave either of them out, the math fails. Now, if you want a quick and dirty rundown of the math, we recommend you watch this short video by Minute Physics. It's simple and easy to follow, and it will give you the necessary insight about why kinematic and accelerative time dilations and contractions need to be taken together. Indeed, saying only accelerative time dilation is real while kinematical time dilation isn't is not only incorrect, it's also not an explanation you'll come across in any textbooks or historical works. So Sabina's being a little disingenuous here in claiming she's teaching Einstein's interpretation, as she's actually just teaching her own. Additionally, earlier in the video, she actually rejects Einstein's preferred explanation to the twin paradox, which is the gravity-based one. Of course, as we discussed earlier, it's likely she's entirely unaware that Einstein even had a preferred solution to the twin paradox. But this just demonstrates our point that nobody knows exactly what interpretation of relativity they are teaching, and generally they just fill in the gaps in their understanding with their own ideas. And here, Sabina's own ideas are quite in confusion, as it's clear she can't decide what level of ontological reality to ascribe to the phenomenon of time dilation. Indeed, physicists being unable to make up their minds about what the meaning of time dilation actually is probably the biggest source of confusion in relativity, and why you get such backwards ideas like time dilation causes gravity. Is time dilation something real, something that should modify our idea of true, immutably flowing time? Or is it just an artifact of how we've chosen to formulate our theory and draw up coordinates? This is where the formalism of relativity doesn't provide any clear answers, and consequently, where the personal interpretations begin to flow. If we want to treat time dilation as something real, then since different observers don't perceive the same manner of time dilation as one another, we seemingly have to accept a solipsistic worldview where different observers can construct different narratives of their existence. On the other hand, if we reject the reality of time dilation, we're left scratching our heads over just how it comes about that certain clocks can be empirically observed to run slower or faster than others. But what if it were the case that there were other interpretations of relativity out there? Interpretations that reproduced the formalism, but which steered clear of the heavy-handed space and time altering pseudo-mysticism of relativity altogether. Interpretations in which there was no time dilation or spatial contraction to begin with, no relativity of simultaneity or funky stretching or shrinking of measuring instruments. Would you feel you deserve to know what these interpretations are? Or do you think physicists should go on teaching relativity as it currently stands? A theory with a perfectly functioning formalism, but with its philosophy caught in a limbo so uncertain that even Einstein couldn't make up his mind about it. Well, we can't make that decision for you, but we can say that if we want to move towards a more consistent interpretation of relativity, we need to re-examine one assumption of relativity in particular: the assumption of absolute acceleration. Indeed, it's this assumption which Sabina uses to justify her interpretation that only accelerative time dilation is real. But it's an assumption Einstein could never bring himself to accept. Indeed, if you want to know Einstein's actual thoughts on the topic, we suggest you read his 1913 paper entitled On the Relativity Problem. because you might be surprised by what you find there. We also suggest you watch Sabina's video more carefully around the 17-minute mark and ask yourself why she says that the spring which is brought in there has to come from outer space. Indeed, a more thorough examination of the problematic notion of absolute acceleration will help guide us towards a better interpretation of relativity. We're saving a full treatment of that topic for another video, but for the moment, we can with certainty say that this statement Sabina gives us at the end of her video is not correct. And rather than clarifying things for her viewers, it merely demonstrates her own confusion about the theory. Which, of course, brings us to the real reason you don't understand relativity. You don't understand it because the people teaching it to you don't understand it. At the end of the day, this isn't a huge deal, as quantum mechanics demonstrates that you can teach a formalism just fine without the accompanying clarity of philosophical principles. However, the first step to overcoming a problem is admitting that you have one, and relativity, unlike quantum physics, suffers from a serious case of denial. But if you, like us, are after the truth, then you know no harm can come of asking critical questions and exploring new ideas. So hold onto your socks, because our channel is about to move into uncharted territory. This has been Dialect. Stay tuned.
Hi. Oh dear. I'm getting music. Music form. Yeah, close that. Right. Hi. Hello. So we're back. Hopefully that has clarified things. Where's Franklin gone? The subject of relativity, as shown here, is a very confusing subject. The experts, or the people who think they're experts on the subject, don't really know what they're talking about. And they have gaps in relativity which they then want to fill up with their own ideas. And they all then have different ideas, and hence relativity becomes something which keeps changing among all these different experts, where they say things that contradict themselves. So we can open up now to conversation, I hope. I'll have a look in the comments. Oh, great, we've got some comments. So somebody thinks it's a Doppler effects, and that's probably what he's referring to as time dilation. Well, that's another issue to start arguing about. If you dialect, so this one. Oh, where's it? There that come? I suppose. What would you say causes time dilation? Question mark. Velocity and with general relativity, gravity. So yeah. So if you go to normal relativity, you've got time dilation in special relativity, and you also got another time dilation being added from gravity. So that is another area of great confusion. But as this video from Dialect is trying to explain, Sabine was trying to get around the problems of time dilation by talking about there being a pseudo time dilation. And that really just makes things more confusing.
Well, I'm curious, what is your personal opinion on time dilation? Is it real? Is it clock dilation? Is time really changing? And
Well,
why is it caused by these three things? It could be caused by velocity, acceleration, and gravity, right?
well, with Einstein, you go back to his paper in 1905. What you're faced with is a problem of how to synchronize clocks, and it sort of comes out from the synchronization. Well, the way he wants to synchronize clocks, that the clocks are going to have different rates of time, and that ends up being called time dilation. But then you can argue it's not really time being affected, it's the clocks being affected. So it should really be called clock dilation.
Well, do you really understand? Because I read the 1905 paper,
Yeah,
and that's when I completely stopped understanding what he was doing.
yeah,
You know, when you say synchronized clocks,
yeah,
like in the old movies where everyone gets all their clocks together and
Yeah.
say, okay, it's now 9 o'clock. That you synchronize your clocks, and then you go off, you can execute your plan at the same time.
Mhm.
But Einstein doesn't explain clock synchronization like that. Instead, he says something about sending a light signal between clocks to synchronize them, which seems to be, I don't know, an absolutely crazy way of doing it. And I don't even understand how that even synchronizes. I mean, how do you synchronize clocks? How do you ensure that two clocks are reading the same thing,
yeah,
sending light signals between them?
yeah.
Because there's a delay and it's getting to the other clock, obviously. So how can that possibly work?
Yeah. Many people have criticized Einstein, saying his way of synchronizing clocks is nonsense. They have argued that's the point, but you seem to have to accept that that's the way he wants clocks to be synchronized for his theory.
But it
And
doesn't
so
make any sense, because if you have the
Yeah.
clocks,
Yeah.
and I don't know, if you introduce movement, so both your
Yeah.
clocks are going that way, and if you presume that, you know, if there's a stable ether or whatever frame reference, then obviously it's going to take longer for it to go this way than to go that way, right?
Yeah.
There's going to be a difference in
Mm.
actual distance traveled.
Yeah.
And
Yeah.
but yet he's relying on this to synchronize the clocks.
Yeah. So many people pointed out it doesn't make sense. They've read it and it doesn't make sense to them what he's talking about. And he is dealing with the clocks in his 1905 paper, and subsequently to that, people then call that Einstein's synchronization of clocks. So what he's talking about there becomes Einstein's synchronization. So that's the way he wants clocks to be synchronized, and people
Well, I'm asking you, does that personally to you make any sense? Because to me, it makes total nonsense.
Yeah, it doesn't make sense.
It doesn't make sense to you either, even you looking at it.
Well, it doesn't make sense.
Just me looking at it, amateur. It's like
yeah, but the people who believe that sort of thing try to make it make sense. So that's where all the one of the places where all the changes start. But sort of like you made an interesting point in the dialect video, you fill in gaps with their own ideas, and that's what the experts do. They fill in the gaps with their own ideas. So you got Einstein's paper, which doesn't really make sense if you just look at it. Oh, it doesn't make sense. So the experts look at it and they try to fill in those gaps, and they come up with their own ideas of how to fill that in. And in the case of Sabrine, she comes up with this idea of pseudo time dilation, which is never talked about at all in Einstein's 1905 paper, and not talked about in his other papers. So it's just a changing relativity all the time. Things get added to it, it just keep getting changed. So that is part of the problem, that people read Einstein's paper, and the people who want to believe it do not accept that is nonsense, what is being said, and they're trying to add extra things to it and hence change it.
Well, do you think the video actually, clarified? Well,
I think the video
the video was trying to answer its question why you don't understand relativity by saying that the people who are teaching it don't understand relativity.
Yeah, that's right.
Very little headway in the how should you understand relativity, right?
But you got all these different experts, and they're telling you their own personal beliefs, and they're calling it Einstein's relativity. and all these experts are not necessarily agreeing with each other. So you've not got a definitive theory. You've just got lots of people having lots of different opinions, and they're pretending that's Einstein's relativity. It's Hydra monster. It's like the story about Hercules. He's fighting this monster. You chop off one of its heads, and 2 more heads grow up. So this Hydra monster keeps growing more heads all the time, and that's what Einstein's relativity is. People keep adding more things to it and changing it, and there's more heads being added all the time. But if you go back to the basic paper, well, it doesn't really make sense. You've got to try to put some personal interpretation onto it to try to make sense of it.
Yeah, well, at the end of the video, he was teasing that, you deserve an answer where, the rulers aren't rubbery rulers and do crazy things.
But that's the next video. That's what he's teasing for further on. Further on, he's trying to tease you that he's going to give his own personal attempt at trying to clarify things as into a theory.
Yet another personal interpretation of relativity.
Yeah.
Correct.
I've looked at the Einstein's relativity, and really the English version is the personal interpretation of the people who translated Einstein's paper. So if you go back to the German, it doesn't really make sense in German. In 1905, the paper doesn't really make sense. And so the people who translated it have tried to add their own personal interpretation onto that paper to try to make sense of it. So you've got a Hydra monster starting straight off from there. And that's why Einstein's relativity keeps changing. People keep changing things. Even the translators change things.
Yeah, so Quest, he says that there's no experimental evidence for relativity of simultaneity, meaning that no one's actually tried to synchronize clocks by shooting light beams between them.
No, the relativity of what you got. Einstein starts with 2 postulates: the postulate of principal relativity and about the constancy of light speed. And I argue that those things are vague. What does that mean? It's vague. When you're looking at it too deeply, those ideas become vague. But then he also then has to add on this idea about simultaneity, the principle, the relativity of simultaneity. And so he's dealing with simultaneity differently to how Newton would deal with it. And so that sounds like he's adding a 3rd postulate to his theory. But then people would start arguing, no, that's, you've got to do it that way to make sense of the first 2 postulates. So it's more Hydra heads.
We've got Nick Percival here, our local relativity expert. Let's see, he was waving, so let's put him up and
put him up. Yeah. Hi, Nick.
Hi, Roger.
Hi, how you doing?
I just wanted to make a couple points.
Yeah.
By the way, I've studied this area in particular for, I guess, 60 years.
Mm-hmm.
The empirical data from GPS and from linear and circular accelerators says that the alleged time dilation, which is really physical process retardation, as Lorentz correctly had it before Einstein, it's a function of instantaneous velocity and not acceleration, except as how acceleration affects instantaneous velocity. So the empirical data on that, acknowledged by all the relativists who haven't looked at the implications of that data.
I don't know.
For instance, in the book Gravitation by Thorne, Wheeler, and Meissner, they say that exactly on page 1055.
Yeah.
I've
read Kit Thorne, and he says things which I don't think other relativists are saying. So when you say all relatives,
no one argues with the Meissner, Thorne, and Wheeler about what they say about the empirical data.
Yeah.
But they may ignore it, but they don't
Yeah.
say, "Hey, you're wrong," because
Yeah.
anyone who runs an accelerator knows that.
Yeah. Okay.
Now, another thing is just the concept of time dilation really is sort of self-defeating.
Yeah.
Because usually when you talk about time, you have the idea of one universal clock going.
Yeah.
Whereas if you talk about a lot of people converging on one another, all going at different velocities, then you have within a very small volume of space, you have time going at radically different times. So that's more or less equivalent to saying that physical processes go at different rates because of their absolute kinetic energy. So, and of course,
that's supposed to be one of the things they come up with. They're banding the universal or absolute time, and it's going to relative time, and that makes it more confusing.
I have another point, and this is a little bit of a repetition, but just to make it clear, in Einstein's 1905 paper, right after deriving time dilation, in quotes, he said, because of this, we have the peculiar result that if someone goes in a round trip, their clock will accumulate less proper time.
Yeah.
But there was a lot of criticisms, and it's pretty well documented that Einstein took that criticism very seriously. I think of Einstein as a critical thinker. I don't blame him for the problems. I blame the people who just accept relativity without really thinking about it. And so in around 1916, he changed that and say, hey, you're right. So basically, he confirmed that the twin paradox was a paradox and led to a contradiction. And he said that he claimed that the acceleration created a virtual gravitational field. And while the math works out to give you the same answer, we know now from GPS and accelerators that that is not confirmed by the empirical data.
So Einstein, he did make a lot of changes to his theory in his papers, but it just gets all muddled up. And what the video from Dialect did point out that Sabine seemed to be unaware of what Einstein was actually saying about this thing, and she was giving her own version of interpretation of trying to handle it, but still pretending it was Einstein's.
Right.
You call it Einstein's relativity when she's not actually going precisely by what Einstein is saying.
Yeah.
But Einstein's very confusing when he keeps changing his mind. I mean, it's all very well being a critical thinker and changing your mind, but what he's left is a series of papers where he's changed his mind a lot, and he's not referred back to earlier papers and saying specifically what mistakes were in those earlier papers.
So basically, Lorentz seems to have had it right, at least as far as we know regarding time, before Einstein. And what Einstein did was take the Lorentz transformations and say that each inertial observer thinks of himself as being in the single preferred frame. So that's obviously an inherent contradiction. And the other problem with the special relativity is basically it's observer centric. So you can't really have a coherent physics if every observer's different view is said to be equally valid.
So the video did point out that there should be different interpretations of the mathematical formalism.
Right.
It highlighted the two ideas you could a Lorentzian way of interpreting that mathematical formalism versus Einstein, and there could be probably even more. And it's admitted in quantum mechanics and physics that there are different interpretations of the mathematical formalism of quantum mechanics, but in relativity, they don't. The mainstream doesn't seem to admit that. They don't seem to address the issue of the different ways of interpreting the mathematics, and that's another area where things get messed up. And it's where Sabrine comes along, and she gives her own what the words she's doing is filling the gaps with her own ideas, and that's what she's doing, filling the gaps with her own ideas, and then she's still claiming it's Einstein's relativity, and that's where and then so not admitting there are different interpretations and just changing it like that is creating a terrible mess. Yeah.
Thank you, Roger.
So that's right. You just good points there. Thank you. Thank you. Yeah. Okay. Franklin, you're back. Hello. Oh, yes. There's Kevcon says, but Lorentz agreed with Einstein. He never wrote, he even wrote a book about it. I don't know particularly what he agreed with. In 1905, in Einstein's 1905 paper, Einstein was discarding the ether, and that gets interpreted as he's saying there's no ether. And then in 1920, you can say, well, he maybe brought it back again. So maybe Lorentz was agreeing with Einstein about there being an ether, but that was from the 1920s. Anybody else? Any more comments? Oh, hey, Frank's back. Well done. Oh, no, it's Dennis. Hi, Dennis.
Hi.
Hi, Dennis.
Hi, Roger. The GPS people like Ron Hess tended to believe that there isn't time dilation. It's just that cesium clocks, which are the only thing, atomic clocks, which are the only way we're used to measuring time, ran faster or slower depending on where they were in a gravitational field and what their instantaneous velocity was with respect to whatever system that was the ether was being dragged along with. Like usually the Earth system, if satellites around the Earth are if the Earth drags the ether, if the satellites were low, the Earth would drag them too, drag the ether at their location too.
Yeah.
And so the idea of time merging into space and space merging into time seems to be nonsense. And the thing is that what needs to be done is to find the physical properties of the ether and whatnot, and then explain this time dilation, supposed time dilation, in terms of physics.
Yeah. So I think it was Ron Hatch, was the GPS engineer who sadly passed away, was on top of all this. Yeah. So I think you're using in the GPS they're using a preferred frame, and by the relativity principle you're not supposed to have a preferred frame. But then people start putting different interpretations on the relativity principle. So someone say that it doesn't deny a preferred frame and so forth and all that. It's just into arguments once again of interpretation of Einstein's relativity. So you got good points there, yeah. But the mathematics, unfortunately, they did merge the time variable with the space variable. So unfortunately, it's in the maths now. So
yeah, they say that there's many, some relativists will say there are many different interpretations, but the basic math is correct. But the basic math is not correct. That's another misrepresentation.
Yeah, I think can't do the equation down, but if you got the equation for the space-time metric, you can play around with it a bit, I think, and then you could sort of like make the time in the unprimed frame the same as the time in the primed frame, but then you make the speed of light different in the two frames, so you can play around with the maths a bit.
Yeah.
If you start,
but you always end up with a
contradiction.
You always end up with a contradiction, because if the math itself is faulty, and so how can an interpretation of that math be correct if the math is faulty?
Well,
the GPS people do not use special or general relativity.
Yeah. See, from my point of view, you can alter the maths and you can put a universal time into things again by using the preferred frame. And so it's modifying the maths around a bit. So I think that is still allowed. But the way they've done the maths in special relativity is you have relativistic time, relative time. And so the clocks are supposed to be going at different rates. And so they've done the maths where that's sort of happening in it. And it all goes back to the idea of what I was talking to Franklin about, was the Einstein synchronization of clocks method.
Well, there has to be a way to synchronize, because the GPS people do it.
Yeah.
But I'm not familiar, to be honest with you. I don't know just how the GPS people changed synchronization, but they before the GPS program was successful, there were a number of papers written by physicists saying, you poor engineers, if you understood special relativity, you'd realize that you can't synchronize the clocks, no matter how hard you try.
Yeah.
And now they claim that, of course, you can synchronize the clocks, and that shows that special and general relativity is correct.
They say that special relativity is correct because you can synchronize clocks. Yeah, well, that's probably them filling in the gaps again.
Yeah,
they're saying one thing one moment, and when the experiments don't seem to agree with them, they're going to say something else about relativity.
Yeah, they don't want to give it up because it's there's a cancel culture out there, and they won't, even though they may have tenure, they realize that they better not say what anything against Einstein's special or general relativity.
Yeah. The engineers using GPS, if they didn't believe in relativity and they weren't going by relativity, they wouldn't bother with the Einstein synchronization, and they just synchronize the clocks the way they were used to it. And that's probably what's happening.
The GPS engineers do have the advantage that they can test their system, and if it reports the wrong position, then they know that their clocks are not synchronized, right?
Yeah.
It's like a bridge builder. It's like, you've done it right because you can run the car across it and the car doesn't fall in, right?
Yeah.
Right.
You just like doing things by math, and it's like there's no car to fall off the bridge, so they never know that they're wrong. But if you're an engineer doing practical things, you know whether you're getting the correct result or not, right? So, I don't know how they, synchronize clocks, but certainly the GPS satellite system is an example of being able to synchronize all clocks in different positions and places and all different motions.
Yeah.
And maintaining it in a consistent manner. So certainly that creates an absolute frame of reference, however they're doing it.
That's what I would think, but I think they've changed the interpretation of relativity with the people who've hit that problem. And it used to be, I think they were saying, no, you couldn't have a preferred frame. I think they're trying to interpret relativity as it doesn't exclude a preferred frame. So they've changed their interpretation of what relativity is saying. But another interesting point, going off the diversions, is there's a program on History Channel probably, and it's called Skinwalker Ranch. Have you ever heard of it? And what they do is they have there's strange lights going on in the sky around this ranch, and so they've been keeping an eye on it and so forth. And what they say is the GPS isn't working properly there. So what is going on with these things? There's anomalies going on which don't really fit into how the mainstream understands physics anyway. So, what's happened to Franklin?
Oh yeah, well I'm still here, so
He's in the background.
James,
Yeah, put somebody else up. I can't.
How should we be interpreting? So let me put up James here. Maybe he can clarify his question a bit more about.
Yeah, James.
Hi, Franklin and Roger.
Hi, James.
Before, I think you asked a great question. How should we understand relativity? And so congratulations to you, Franklin. I think that was a great question to pose.
Yeah.
So, Roger, how should we interpret it? I mean, what do you think really is going on? Do you have a personal...
Well, I was pointing out that the...
slows down clocks?
That relativity, what they say about relativity keeps getting changed. So they say the experts say lots of different things. So.
Well, that's true, but I was wondering whether you personally, do you have your own personal interpretation of why, say, velocity slows down clocks and why gravity slows down clocks? And
yeah, well, I go back to the original paper in 1905 in German before it got changed by the translators trying to make sense of it. And from what I can understand, it's still just Newtonian physics. Einstein is not saying he's doing anything different to Newtonian physics. You've got the ideas of things like Galilean relativity being different to Lorentz transformations, but that comes after 1905. In the original 1905 paper, there's nothing about Galilean transformations and Lorentz transformations being different theories. So the way I look at it is sort of like it's just misunderstanding Newtonian physics. So when you add in all these extra effects like time dilation, it's just making a bit of a mess of the mathematics. It's all just Einstein's mistakes.
Well, I don't know that Galilean relativity had anything to do with time.
No, in Galilean relativity, you've got absolute time.
So the thing is, how did this effect with clocks come into play?
Well, in Einstein's 1905 paper on special relativity on the electrodynamics of moving bodies, he says nothing about Galilean relativity. He just gives no mathematics about Galilean transformations. He just talks basically about Lorentzian transformations. And he's not saying he's got a different theory to Newtonian physics. So based upon those constraints, that's the original German, and not being based upon how it's been translated by the translators later who are trying to place their interpretation onto it. There's nothing in the paper that is being said that I've got a different theory to Newtonian physics. And so when you look at it, you say, well, he's just making mistakes. And he's putting on this idea, which subsequently became called Einstein synchronization of clocks. So it's just the peculiarities of how he wants to do the maths and the way he's doing the mistakes in the maths. So that's my view on things.
Well, it just seems that, say, Newtonian physics still doesn't have anything to do with time dilation.
Yeah.
Seems to me that the only way that we get this time dilation thing is if we do that whole like light mirror thing where a particle is going
Yeah,
this
that's
way.
it.
But then when you start traveling that way, then it has to do this zigzag thing.
Yeah,
See, so
definitely.
now it's traveling the longer path. See,
Yeah.
so that's how I see that. Somehow they get the time as being defined by a ball bouncing between two walls, and you measure the absolute distance that ball is traveling.
Yeah.
And if you build a clock out of that,
Yeah.
then that clock will run slower as velocity increases, right? So, to try and answer James's question, I think that is, I think that's how it's mostly explained, Einstein's relativity. They always show that particular picture where the ball.
You got two observers, and they're moving relative to each other. So when they're looking at the light bouncing between the mirrors, they're got one observer who's looking at his clock and saying the light's just bouncing up and down, and the other person who's moving relative to that says, "Oh, I can see the light moving in a zigzag." So you've got that sort of thing going on. But if you get
an interesting point made by one other person in the forums, that actually a light clock would never work because light doesn't never travel in a diagonal direction. That if you did that, then the light beam would just simply miss the next mirror as it moves. That
violates the relativity principle.
But this would actually only work with like a physical ball, which has inertia. The
light has inertia.
Well, I think it in the case of a laser beam going back and forth between two mirrors, that if the mirrors were going fast enough, the laser would simply just miss the mirror as it moved out of the way. But because
light has inertia, so you got light has momentum, so you've got the momentum of the mirrors. If the observer's seeing the mirrors moving, those
the trick is that
mirrors have momentum, and also the light has momentum. So you're doing.
And I think you have
some of the momentums.
The point is that the thing that's bouncing up and down definitely has to have inertia in the sense that it has the same velocity. It would maintain the same velocity as the mirrors, like a physical ball in a train moving at 60 miles an hour would move at the same speed as the mirrors inside the carriage. And then if you were to bounce the ball between the walls, then you could clearly trace out a diagonal longer distance that it now has to travel. But that was just an interesting. I mean, I guess you could argue about it whether a light clock worked that day. Although I tend to agree that a light clock wouldn't work.
Well, the mainstream say the light clock would work.
Yeah, the mainstream say that, it probably would.
The light clock is a simplification of the Michelson-Morley experiment. You've got the light bouncing up and down, and its light's going that way as well. And so really it's just a simplification of illustrating the Michelson-Morley experiment. So the mathematics they're doing for that, they're saying is the same as what the Michelson-Morley experiment is doing. So it's based upon experiment. They're saying that's the mathematics for it, which they get from experiment.
Yeah, but I was
they're saying that light has momentum. Light has So you've got the mirrors with momentum. If you're observing the mirrors moving, then it's got momentum, and also the light's got momentum, and so you're doing a vector sum of those momentums. But where it gets confusing is when you add the idea of the speed of light being constant onto that, because then you're saying, well, light's going a longer distance according to one observer than what the other observer is seeing or observing, and so it's still the same constant speed. Therefore, time has to be different. That's where the problems on that bit's coming from. It's imposing onto them that momentum situation. You're posing on the idea of light speed is constant. So you've got people disagreeing about the distance being covered by the light in a certain amount of time.
Now, I think with the video, this is kind of pointing out people struggling to explain. Really, they're not really explaining the formalism of relativity.
Yeah.
The formalism of relativity is just the Lorentz formulas, right?
Yeah.
And that is just experimentally measured. And that is probably pretty much unquestioned. The question is when people try to extend it to, say, gravity, right? So they were mentioning that people were saying that time dilation causes gravity. Right?
No, Sabine was saying, first of all, Sabine was dismissing time dilation from a kinematic situation, and then she was wanting to bring it back in with the gravitational situation, but that was her personal interpretation.
Yeah,
when you got time dilation from both special relativity and from general relativity, it's just another confusing mess. But basically, really, what you should be having is saying the teacher's teaching it, saying, "Here's the mathematics." That's the mathematical formulation, the Lorentz transformations, and all the rest of it, and saying Lorentz has this interpretation of that mathematics, Einstein has his interpretation, Sabine has her interpretation, and so forth. So you've got the same maths but different interpretations of what that maths means. If you go back to the equation E equals mc squared, I think we've argued about this on the discussion. What does that equation mean? Well, some people take that to mean mass m can be transformed into energy E, and other people say, well, no, it's an object with mass m and it has energy E. So you've got this problem of how do you interpret that equation. You've just got a simple equation, E equals mc squared, and you can impose different interpretations onto it. And it's the same sort of thing with any of the maths which the relativists give it to you. You can start imposing different interpretations onto it, and you can start doing a bit of algebra manipulation and make it look different.
Now, Harry here, he says that even the math formalism is wrong.
Yeah.
But does that mean that the experiments are wrong? I mean, let's bring up Harry and see what he has to say about that.
Okay. Okay. Hi. You can talk.
I have a couple of problems with this discussion. Can you hear me?
Yeah. Okay. Cheers. Thank you.
I have a problem with the video. I think the guy in this presentation in his video made a number of errors in his video. And I think the premise of the video is questionable and should have been discussed first before we got off on all these tangents that people have gotten off on.
Yeah.
And the first thing is Einstein wrote a book. Here it is.
Yeah.
Talks about his interpretation. Have you seen this book? This book was published around 1920. Anybody who talks about relativity should have read the book.
Yeah.
Am I not correct on that?
Yeah, that's his book. Yeah.
Okay, then he's got another book. Here's his other book. Here's his other book, The Meaning of Relativity. Have you ever? You should read this book too if you think you're an expert.
Yeah.
Okay, so this is. I mean, so he wrote two books talking about relativity, and there were not. So, Einstein, this is where his interpretation. Well, okay, we can go further. Okay, here's Pauli's book.
Yeah, that's Pauli.
Okay, written in 1920, which is essentially his, how we call this, a synthesis of what Einstein wrote and Minkowski wrote, and it kind of summarizes the theory of relativity up till 1920. And a lot of people think this is really what you should be talking about when you talk about the theory of relativity. Okay, you should be talking about what Pauli says, not what Einstein said in 1907. That's kind of a mistake, because what Einstein wrote in 1907 is kind of his first cut at it. his first attempt. And then he had several other attempts after that. Okay. And then Minkowski got involved and other people got involved. And then this is kind of the synthesis of that after World War One. Okay.
Yeah.
Now, here's Bergman's book. Here's Bergman's book.
Yeah.
Okay. Bergman was a student of Einstein, right?
Yeah.
So this book should give you what Einstein, as I understand it, they had offices in the same building. I might be wrong about that, but my understanding is that Bergman was a student of Einstein. And so he should be telling you what Einstein is thinking in this book.
He doesn't.
So I disagree with the statement that Einstein never wrote what his theory was or never had a real. So I disagree with that.
Well, if you look on the book, The Meaning of Relativity, he is adding more to the book. He's doing updates to that book, which is kind of like the final book on relativity from him. But he's also not making statements that what he said in previous papers he got wrong. He's not pointing out where those errors are and so forth. And he's also not giving a unified theory of explaining how you combine electromagnetism with gravity. So it's still a theory in the progress.
Well, I'm picking on a fine point, which is the statement was made in the video that Einstein never gave a. Okay, I think he did.
No.
Okay, and what people do is they go back to the 1905 paper. Okay, and then that's a first cut. The business we were discussing earlier, I think Nick brought it up about the peculiar result. He makes a statement about the peculiar result about time dilation. That was removed in the following paper in 1907. That doesn't appear in 1907 paper. Mm-hmm. So obviously, he's changed things.
In the 1907 paper, does he explicitly say what he said in 1905 was wrong?
No, but he leaves out things, and particularly he leaves out that example. So my impression is that he's not repudiating it, but he's not repeating it. So I agree that this is an interpretational issue, but the point is you can get confused if you go only by what he says in 1905.
Sorry, impression is another way of saying interpretation.
Well, but I'm saying that Pauly supposedly, here's Pauly's book. Okay, this is supposedly the final interpretation. Okay,
I don't know if it's
my understanding is this is supposed to be the final interpretation as of 1920 when this book.
It's 1920s interpretation.
Okay. Yeah. Okay, and so then you have this meaning of relativity, which was in the 1950s.
Yeah.
Okay, so
but
now
I
would agree.
You've had. Yeah.
I would agree that people have different authors have different interpretations of it.
Yeah.
So, for instance, Einstein doesn't talk about the light clock. Okay, you were talking about the light clock. That doesn't appear in Einstein's theory. That's not part of Einstein's theory.
Yeah.
Okay, so get clear on that. That is Lewis and Coleman's theory.
Sorry, you go back. Einstein is talking in 1905. He's talking about light traveling along a rod, going backwards and forwards. So he is sort of bringing in the idea, which then became later called a light clock. So it is the basis.
Yes, but my point is that's not really part of Einstein's theory. That is Lewis and Tolman, and I don't think that it's in the Pauly book. Okay. And I don't think it's in the Bergman book. Okay. But then other people have brought it into the package. So what you have is you have Lorentz and you have Maxwell and Lorentz, and then it's evolving along. And then Einstein publishes the paper. Then Minkowski gets into the act, and then von Lohe gets into the act, and all these other people start. What's his name? Planck gets involved in it too. And all these people get involved in it. And the twin paradox gets brought in by Langevin. Okay. And then so at the there's a lot of confusion because you have a lot of people who are saying, I think relativity is this.
Well, they're not using the words
Okay.
I think that. They're actually,
I think Minkowski is a good example of that.
What they're doing is they're pretending what they're saying is Einstein's relativity, when actually they're putting their interpretation onto it.
Well, no, I think it's different from that. I think it's like Minkowski has his own idea. Okay, he is sort of taking what Einstein is saying and then transforming it into his idea. Okay, but then later when it gets mashed together, okay, it sort of just kind of becomes Einstein's theory, and these other people who are involved in it don't get all the credit. Yeah. So, for instance, when you're talking about the light clock.
So Einstein initially disagreed with what Minkowski was saying, and then later he changed his mind and he brought what Minkowski was saying into his theory of relativity, and then he brought in the idea of you having differential geometry onto that. So, and he was taking it putting that on top of Minkowski.
Right, now you will see,
and then that gives general relativity.
Now he doesn't really talk about Minkowski too much in this book.
Yeah.
Okay. This is more of the traditional theory that he would have talked about in 1905. But you'll see in the Pauli book, Pauli sort of does integrate the Minkowski ideas into it in Pauli's book. So Pauli's book is sort of integrated what Minkowski says.
Yeah.
And that also carries on because you'll see it also in the Bergman book and then the later, so the Minkowski space-time sort of gets brought into relativity, but it's not there at the beginning in 1905 and in the 1907 papers. It's only later, okay, that the Minkowski gets fully integrated into Einstein's theory of relativity.
Yeah, okay. I think Minkowski was 1908 when he came up with it.
Right. Okay.
Sure.
Now,
but Einstein took a bit of time before he accepted what Minkowski.
Okay, so there's all these. There's a lot of disparate ideas.
Yeah, and a lot of things coming together,
and they're all trying. And so the teachers are trying to put it into a package.
Yeah,
I don't really think. I notice here that Pauli doesn't. He calls it theory of relativity. He doesn't call it Einstein's theory of relativity.
Well, he's not making it explicitly clear. I don't think there's any other version of the theory of relativity than what Einstein's is.
Well, I think what he's saying, he's not saying this is Einstein's relativity. Okay. And I think that's part of the problem is when people say Einstein's relativity, Einstein, you could just as easily by that reasoning call it Lorentz's theory of relativity because Lorentz.
Well, some people think it's Lorentz relativity.
Some people say there's but it's essentially Einstein's become the most famous name associated with the theory of relativity, which is not an invention wholly of Einstein. Okay, that's the point I'm trying to get at. Einstein
he suddenly became promoted a lot in the news media in 1919 as this super genius, and everything ends up being attributed to him as a genius. So it all comes to Einstein. And all the other people that have been working on it, they sort of they forget.
Okay, here's another point I want to make about this. Now, there's really two primary divisions of what you would call theory of relativity. There's the kinematical part, okay, which deals with the space and time, and that's where all the controversy arises. And then there's the dynamical part. Okay, which is the relativistic relativistic mechanics part. And they're kind of treated differently. There's a different formalism. Like, for instance, the kinematical part uses Lorentz transforms. Okay, and you solve. But when you go to the relativistic part, it's 4 vectors is the mathematical formalism. Okay. And so you have different mathematical techniques in these different things. So when a guy, sometimes it's confusing when you see a video and the guy's talking about 4 vectors and you thought he was talking about Einstein's theory of relativity. Einstein doesn't say anything that I know of about 4 vectors, although Minkowski talks about it and Bergman talks about it in his book. That got added into the into the formalism later. Okay,
it all gets more stuff getting added into it, and I don't
so
think
you gotta. So it's confusing if you want to say it's the 1905 paper. That's just you can't go by what he said in 1905. It's just too early on.
He's changed things. Things get added and changed from 1905 onwards.
Okay, correct.
And that process is still ongoing even today. Like Sabrine, she was adding.
All right. Here's the point. The guy in the video says that the formalism is correct. The mathematical formalism is correct. I don't agree with that, and that's where I think the problem is. And people just assume the formalism is correct, and then move on, and then you have a lot of controversy after that. But I do want to bring up this issue about Sabine Hossenfelder. My understanding is, now Nick can correct me on this if I'm not wrong, but in 1918, Einstein wrote a paper that attempted to resolve the twin paradox. And he did that by invoking acceleration. And since then, the books on relativity and the experts have always brought in that it's the acceleration that distinguishes between the 2 twins. And that resolves the paradox. So the official mainstream answer has always been that it's the acceleration that resolves the paradox, right?
Well, I don't. Mainstream do give different versions.
So that's not. I don't think Sabine Hossenfelder is making anything up when she says that. She's saying that's based on what Einstein said in 1918.
What she was doing, she's adding this idea of pseudo time dilation, and there's also a real time dilation. So she was adding the idea that
all right, okay, now that's a good issue. Now we can go back. We can go back and talk about that because I was a little unclear. She used this term coordinate time.
Yeah,
as I recall, she used this term, and I didn't understand what she meant by that.
She didn't really go into
the difference. Right now, there's proper time and coordinate time, and this is where it kind of got fuzzy to me, and I didn't really quite follow that part. Now, Nick, I think knows more about this than I do, and if Nick knows has some clarification on that, I appreciate that. But my point is, I think what Sabine Hossenfelder said, despite the fact that she said pseudo time dilation, that part maybe was her understanding, or I'm not sure where that came from. I agree. But the bit about the acceleration, that I think comes from Einstein in his 1918 paper and has become the classic explanation for the twin paradox that you'll read. And
with Einstein, I think by the equivalence principle, you've got the gravity and acceleration being equivalent.
Right. And he goes into that in his
gravity. So when you bring in acceleration, presumably you're bringing in gravity.
Right. Now, but that's in a paper that Einstein did in 1918. Okay. And my understanding is that mainstream believes that he resolved the twin paradox by doing that. And then, but there's been arguments back and forth, so, there's still people who don't believe it and don't really agree with it, but that was Einstein's resolution of it. That's my understanding that was Einstein. So Einstein did resolve that or tried to. Mainstream thinks he resolved it because they quote acceleration as a resolution of the twins paradox.
Often,
so apparently they agree that he solved it there.
Yeah,
that's what they teach.
They do actually. Some of them, ones the popular videos on the twin paradox, they do try to work around the acceleration issue. We haven't really gone I haven't really discussed the twin paradox. I could have showed that there's different people saying
Well, that
different things
video
about
was
that.
based on the twin paradox. That was what he was talking about.
Mm-hmm.
Yeah, that was because the issue is that people can't accept time dilation. It's a non-Newtonian concept. Newton has absolute time and absolute space. And
Well, Einstein, sorry, Newton, he does admit there's relative time and relative space as well.
Well, yeah, but it's that's a terminology thing. But basically, Newton's idea is that time is absolute. It's mathematical time, which is really the point. It's mathematical time. Okay, and Einstein's time is mathematical time too, but it's different for each and every observer. Okay.
Yeah. Yes. Yeah.
Okay. So you can think of Einstein as it's Newton, but every observer is in a privileged frame. And so every observer has a different time and a different space. That doesn't make much sense. That gets you to
Einstein relativity don't make much sense when you talk about it too much.
Well, the problem is it says that the universe is not unique. So no two observers can agree on the physics of the universe because they each get different physical results when they do an experiment. So no two observers are going to be able to agree on what the universe is.
Well, you're supposed to be, from Einstein's method, you're supposed to try and work out what observers are going to agree about when they make observations. And sort of like starting from 1905, but maybe you don't like, is basically the idea.
Well, you can't do that with relativity. That's the problem.
1905, if you start them there, it all gets changed. But you're supposed to be the observers agreeing for the same value for the speed of light. So
that's assumed as a postulate.
Yeah.
Yeah. Okay, but then that results in everybody's got a different time. Everybody's got different time and space measurements, and then they can't agree on those measurements.
That's right. Yeah.
Okay, so that ought to tell you right there there's something faulty in the postulates, and those postulates then lead to faulty mathematics.
Well, that's right. They should go by what Einstein's saying and say that it's faulty. Assuming what he's assuming doesn't lead to making sense, but the mainstream doesn't seem to accept that they're doing what he described as filling in the gaps by their own personal beliefs, their own personal ideas, filling gaps with their own ideas. So when it doesn't, if you go precisely by Einstein,
let's go back to the situation. Okay, so what they have is they've got this problem. They have this theory. Okay, and then some it's a theory that's not based on experimental. Einstein was not an experimentalist, and so Einstein could probably never do an experiment, never design an experiment. He's completely incompetent in experimental physics.
He did. I think he did experiments when he was at.
Maybe. Anyway,
learning physics.
He shows no understanding of experimental physics in any of his papers.
It's supposed to be that Einstein got his ideas from thought experiments, where the typical one is he wondered if I was traveling at the speed of light, I had a mirror in front of me, would I be able to see my face?
Okay, so now you see here Castro is saying that I'm completely 100% wrong, right?
Yeah, that's different. That's different opinions about relativity. So some people,
if what I said was wrong, we wouldn't be having this conversation about it. There would be no point in talking about it because there wouldn't be any confusion in relativity, right?
when they teach relativity, what they usually say, but they don't always say, is it's based on the experiment, the Michelson-Morley experiment. So that's the experimental evidence you're supposed to believe. But I think the trouble is you go to Einstein, when they asked him about the Michelson-Morley experiment, one time he said he didn't know about it, another time said, yeah, the theory is based on it. So he changed his mind. So when you come to the idea of is Einstein's relativity based upon the Michelson-Morley experiment, Einstein answers both yes and no.
Well, it's just another example of ambiguity. So, so he's got a theory in 1905. He doesn't even mention the Michelson-Morley experiment in 1905.
That's correct. That's
Then
what
later
they
he
asked
brings
about
it
it.
in. Later he brings it in 1907 in the later
Yeah.
papers. And so, oh, hey, you know, this experiment, this Michelson-Morley experiment proves my theory.
Yeah.
You know, but he never said anything about it in 1905. So that's confusing.
That's correct, because that's also what they asked him. Did he know about Michelson-Morley experiment in 1905? And his answer is both yes and no. It depends on when you ask him. You answer differently.
Okay, so to get to my point, okay, so you got these experiments that appear to verify relativity. Okay.
Yeah.
And so they're so committed now to the formalism of relativity, the mathematics of it. Okay. They're committed to that. And then the problem is that you get into all this twin paradox, and people don't accept the kinematical explanations that you run into in special relativity, the kinematical part.
That's why Sabine was trying to get around that bit.
Right, the twin paradox and all that.
Yeah.
That just does, basically people just don't accept that. That's you know, just something. But now the scientists are committed to this absurd formalism that predicts, that leads you to you know, these absurd conclusions about space and time and gravity and time dilation and space contraction and all this stuff. People just can't accept that. That's what the controversies are about. That's why we're sitting here talking about it. People can't accept it. The formalism doesn't really look right. Okay. It doesn't, you know, the mathematics doesn't, it makes predictions that just don't seem to agree with common sense interpretation of reality. And then they're telling us, oh, but physics tells us that common sense reality is wrong. I love that part.
Yeah.
Oh, okay. So
that's it. That's the situation. Yeah.
So this is just, you know, as far as I could tell, you know, the physicists got a real problem because they can't admit that the formalism that they're basing everything on is flawed. And so they have to maintain that. And it's full of contradictions. And so therefore they just keep trotting out the contradictions, and people keep, the more people think about it, the more, you know, they think it's wrong. That's the bottom line.
Yeah.
So anyway.
Yeah, that's it.
I don't know that the guy in the video really, I mean, I didn't really agree with a lot of what he had to say.
Yeah.
I don't really, you know, I noticed that he had our good friend there from, I can't remember the guy's name. We were talking about him before.
John Lincoln, is it?
Don Lincoln. Yeah, Don Lincoln. You know, and I watched his videos, and I just shake my head. I can't. You know, I just see so many contradictions. In one video, he says one thing. In one video, he said that the lifetime of a photon was 0. In another video, he said the lifetime of a photon was infinite. And you know, he didn't even see there was a contradiction in saying those two different things, because formalism allows you to say either of those two things are true.
You saw the video some time back, which we had on this discussion, relativistic mass. When he talked about it, he suddenly given his opinion of relativistic mass at the present time, and he admitted that he'd been talking about it wrong in the past. So he does admit that he's changed his mind. He's saying one thing.
It's kind of hard for them to make sense out of a mathematical formalism that's flawed. And they don't even understand why the mathematical formalism is flawed. And that's a more serious problem. Now, there are some mathematicians, Zbigniew Ostrowski or whatever, this guy that's in Mexico, I think is an expert mathematician. He says the formalism's messed up.
Yeah. But given I would say, given the mathematical formalism, they do say that mathematical formalism fits experiments. And I would say it fits certain experiments. And if you alter the maths around a bit, well, adding more things to it and so forth.
Only if you look at it from one frame of reference.
Yeah. But that's all just
you operate in one frame of reference. Yeah. If you try to reconcile the formulation for different observers, you get contradictions, as is well known.
Well, it depends, doesn't it, how many observers you can bring into it. Normally, you just
formula is wrong in the sense of like the twin paradox still shows up, right? Is what you're saying, Harry?
Well, the twin paradox shouldn't occur if you had correct mathematical formalism. That should never have arisen.
Although experimentally, if you do the individual experiments where you inherently assume there's like, one stationary frame, as Einstein says that, yeah, then all the experiments work out. I think it's, as you say, when you start considering two different observers, giving them equal footing, that's when things really run off the rails. But otherwise, the Lorentz formula itself technically predicts, like the lifetime.
Well, the Lorentz formula works if you're only assuming one frame of reference. The Lorentz formula works fine if you assume one frame of reference.
Yeah, so I think that gets to maybe the point.
But you can't do it. You can't go back. You can't use the Lorentz formula and go backwards. When you do that, you get paradoxes. That's because the mathematical form, the assumption that of the postulate of relativity is false, that every observer is in a preferred frame of reference. And then what they do, that's where the mistake is.
Well, getting back to maybe how we can solve this, I mean, the way to, I don't know, make progress on relativity is to come up with, say, a replacement theory that explains.
Well, I already solved that in my papers at the GSJ. All you have to do is go to the GSJ, look up Harry Ricker, and read those papers. It's already solved. I already solved it.
Oh, okay. Well, I'm interested in what your particular solution.
I mean, haven't I said that? How many times have I told you this, Franklin?
Well, for the edification of our audience here, I mean, let's hear it.
Go see my papers at the GSJ, General Science Journal, Harry Ricker. It's all explained there.
Is it? Well, we're discussing it here. I mean, me personally, I think we do have to get back to, say, Newtonian physics, where there is absolute time and perhaps a sense of absolute space. I mean, would you agree with that? Is that part of your solution?
Depends on what you mean by those concepts.
Well, for example, in order to make this, I don't know, physically real, you might want to consider what you have to describe what vacuum space is, for example. And if we considered that it was filled with some tangible particle or something like that, I don't know what that may be, but that would define an absolute space, for example, right? So if you take the room and you filled it with balls, then you could define.
You're completely off on the wrong concept. Absolute space, that's philosophy. We're talking about mathematics and physics, not philosophy.
Well, if you took a room and you filled it with balls, then that would certainly define a fixed absolute frame that you could measure the velocity of any particle.
Physics has absolutes, and they're called standards of measurement. And what you do is you have a standard of measurement, and you do measurements based on your standard. Okay, and that's the concept of absoluteness in physics.
Yes, and I'm saying that the only way you can do that is to establish such a physical fixed frame, right? You can't do it.
You have one.
If you have like an empty room and there's no references in that room, then you can't really say what the velocity is.
You're talking confused philosophy as usual, Franklin. I have no idea what you're talking about.
It's a very, very, very fixed and not possible to confuse philosophy, right? If you're going to measure something, you have to have points of reference to measure those things against. So I think you have to put something in the space so that you can physically see those measurements.
I don't know
right?
what you're talking about, Franklin. Putting something into space. I don't know what that means.
Mm-hmm.
Do you know what, filling a room full of balls would be, right? You know what that is, right?
We're not talking. We're completely off and on an irrelevant subject. I'm sorry for interrupting, Roger.
Okay.
No,
Can we
I'm
get
just
back
trying
to the topic we were discussing?
I would still like to find out what your personal solution to this problem is, and it's not satisfying to
What
say
problem
that
are you
my
talking
papers.
about?
It's really not. I mean, you can explain
What problem are you talking about?
to explain, for example, what actually causes time dilation. Why does gravity also affect clocks, and what is this? What is the effect of, say, acceleration on these clocks as well? That's the problem that was addressed. What I was trying to
So
address.
you're asking for causes. I don't have an explanation of the causes. All I have is a mathematical solution to the contradictions that arise in special relativity, which is a well-known solution that's well established in mathematics and is well known.
Okay, so that's fine. I mean, it's perfectly fine. I think it's better for people to admit that they don't know what the causes of say how gravity affects a clock. I mean, that's good to know what your explanations are going to or not going to explain. But I suppose on my own personal standpoint, as a physicist, I would like to know what those physical causes are. So perhaps that gets back to, how, for example,
I would too, but we obviously don't have that knowledge at the present time. We don't have that knowledge at the present time. So
waving his hand here. So let's see what Nick has to say. What you got to say, Nick, here? I think you're muted there, Nick. You have to unmute yourself.
Yeah.
I think Roger has done an excellent job in saying that, much as I respect James Keen, that the issue isn't how should we understand relativity, because it is so many people have different views that's sort of a red herring. What we should do is more like what Franklin initially suggested, is to find out what is the real physics behind that. And to do that, at least in the area of time, that's where I know the empirical data. And in that area, the empirical data says that Lorenz's original view and the Lorenz's original Lorentz transformations, which are qualitatively different than Einstein's messing up and having totally different Lorentz transformations that are at the opposite end of the physics spectrum. And what you find from the GPS data is that its velocity, its absolute velocity, which in the locale of the Earth is velocity with respect to the ECI frame, the Earth-centered non-rotating frame. And if you use any other frame, like special relativity does, or says you can, you get the wrong answer. You send people into the lakes. So the only time that the experimental data agrees with special relativity is when it also agrees with the totally different Lorentz physical theory of a single preferred frame. And all the other data, 99% of the data from GPS radically disagrees with special relativity. If and only if you take the single preferred frame approach and the physical model of Lorentz does the degree. And that's per Ron Hatch, who knew the data the best and has 30 plus patents in the GPS system. He certainly knew it extremely well. And,
should
and
we
all the data from CERN agrees with that. All of the time dilation, or the half-life data agrees that you only get you get the most accurate result if you use the ECI frame, the Earth-centered non-rotating frame. And what I've come up with, this is just speculation, is that that's the non-rotating gravitational field of the Earth. So in that way, you don't have two separate phenomena like the velocity effect and the gravitational potential effect. Basically, atomic processes are affected by their position and their movement within the gravitational field. And I think this is again speculation. I think of the gravitational field as acting kind of like the ether. So it's motion with respect to the ether, and the physical cause is that it's the energy of the environment, absolute energy of the environment, that causes atomic processes to slow or speed up, depending on which way you're going. So that's just a little bit of speculation. Now, since I'm saying that, I'll go on to say one other thing, and that is I think that the concept of time is a red herring. I think that that concept was invented by humans because they see a myriad of things changing within three-dimensional space. And the only way to understand all these things that are going at different rates is to have a generalization. It certainly makes it easier to talk about in most everything except foundational physics. So I think I replace the concept of time with process length. And one would develop a single process to go with. And that's how actually we've always done it. It started off by defining the day, the year in terms of the motion of the Earth, and the cycles of the Earth. And even today, our standards talk about it as the second is the number of vibrations of the cesium-133 atom in its ground state. So in that sense, we're talking not about some philosophical concept of time. If you look at the writings of the philosophers of the last 2,000 years, they've made no progress whatsoever, and they just had confusion. Think in terms of it purely in terms of how motion and the gravitational potential affect the process rates. So the one thing we know for sure from the GPS data is that absolute velocity with respect to the GCI frame causes slowing of atomic processes such as the cesium-133 atom. And in addition, the position within the gravitational field also affects atomic processes. And actually, that latter part is in agreement with general relativity. The gravitational field equations of general relativity are non-relativistic, and what the GPS data shows is that the equivalence principle that extends those non-relativistic principles, non-relativistic equations, is incorrect. So all of the broadening of general relativity that is based on the equivalence principle is incorrect, as the data shows. So there, it looks like we have, that's a possible physical interpretation. and a common cause, namely motion or position with respect to the gravitational field. So that I think would be along the lines of what Franklin was looking for.
Yeah, I mean, that's I guess at least an attempt by saying that gravity has, I don't know, this energy effect.
Yes.
Although, you brought up the whole ECI thing. So I was thinking, the world is consistent with, say, the idea that space is quantized. Like you could just imagine drawing a graph grid in 3 dimensions, center that on the Earth, and then use that to measure absolute velocity, and then you get the correct results, right? Now, whether that's
certainly James Keen would agree with you, I think, on that general thought.
Yeah, because James Keen said, if this whole world is just a simulation, then in fact, your computer could define the coordinate system in that fashion. Literally put a graph in space, hang it on the ECI, and then the observations appear to be correct. For me, the sense of time, I would also go back to Newtonian and establish absolute time, which would just be the minimum amount of time for any effect to propagate from one spot to the next. So that would essentially set the speed of light, right? So if you have point A, point B, reaction can only happen that fast. And if you put a whole train of those things in, that's the speed of light. And anything traveling through that space would also obey that law, because we also have to make it so that, that the whole clock thing, so that when it starts doing the diagonal, that it actually takes longer. So there has to be some physical thing that makes that path longer. And if there's just a speed limit for when that thing is going diagonal, then it must simply take longer to go to that diagonal, because it can only physically travel the same distance over absolute time. So I think that makes it explain, why physical clocks like a pendulum, I don't know why atomic clocks slow down, but if you're thinking like a pendulum swinging through space, then that pendulum would swing through more space on a moving train. So
yeah, but a pendulum rate is dependent upon its gravitational potential, and then rather than slowing down like general relativity says, it would speed up.
No, I think we just kind of ignore that, because I just don't like talking about the light clock thing. But something bouncing elastically between 2 positions, can be done. I just think it's easier to understand with the pendulum than a light clock, because I don't particularly believe the light clock. But the thing is that now you mentioned, say, gravity, because people try to put gravity to explain why the clock slows down, and there are some energy, but that's kind of like, well, then why does energy slow down the clock? And there's still no explanation there. But I wanted to appeal to gravity causing a different effect, which is actually compressing space, right? Because I said that the amount of time it takes to go from point to point, that establishes absolute time. But the trick is, what happens if you take those points and you compress them? So now it will take actually longer for it to go through, to reach the same distance, right? Because I think we also have to bring back.
You get that same effect just by thinking about its motion through a stationary ether.
Yes, well, it's kind of the same effect. It's either because the time slowing is caused by essentially how many particles it has to go through to reach from point A to point B. So if go from point A to point B, you go through 10 particles, it's say in a stationary position. But if you're moving at high velocity, you might have to go through 20 particles to go the same distance. So that explains. That's a way to explain physically time, why that clock slows down, because now that it has to go 20 particles instead of 10 particles.
Yes, and Ron Hatch.
Just a minute. Let me finish
Ron Hatch had the same idea that it was the
explain
density of the ether.
Yeah, that's what I was trying to get to. That another way to achieve that same, like point A, point B, is to actually literally stuff 20 particles between point A and point B. Then once again, it will take twice as long to get there. So, if Ron Hatch was saying that, gravity can compress space, essentially takes that graph and squishes it down, then that's another reason why we could possibly relate gravity to clock dilation. I like calling it clock because it's the clock that's slowing down. But I believe in absolute time that you should, and I'm still holding out hopes that someone can build a clock which is actually dependent upon that very smallest unit of time from particle to particle in space. You build a clock based on that, you would find absolute time. And then we could dismiss this whole time dilation.
Okay, I agree with much of your thinking, but I really think that absolute time is a red herring.
I think it's a critical, I think in order to make...
Well, tell me one time when we actually measured time itself, rather than some physical process.
Well, we know that this instance is different than that. See, my hand was over here, now it's over here. So we have directly measured a time difference happening, right? We didn't have any clocks to do that. All we had to do is
that's just what you've measured is some aspect of movement within three-dimensional space.
Yeah, but I would define time as being any change of state. So anything that can demonstrate a change of state in any system demonstrates time. Like if I were to just freeze, then
I don't think we should get into too much detail. I think, I had my speculation, you have your speculation on that, but I think that's more productive than trying to say, okay, let's get the ultimate definition of special relativity, because it has so many foundational flaws, one of which Harry pointed out. And everyone seems to change special relativity because they notice certain aspect that's unsatisfactory about special relativity. Talking about the twin paradox, we have in the very top journals, we have more than a dozen papers saying, oh, here's how to reconcile special relativity with the fact that clocks lose a slowdown with a velocity, but all those 12 were different, and therefore 11 of them disagree with the other any of the other papers. But there's no paper in the high level journals that says, hey, there's a problem with special relativity in this. No one seems to agree.
So Nick, the reason why you can't do it is because we're building castles in the air. We essentially have no firm physical foundation for like the establishment of what time is and what space is. So that's what I'm suggesting, that we do need to establish a firm, well, at this level, you have to postulate it, but to postulate that, say, space is quantized, time is quantized as an absolute value, and say that time is just the change is the occur in a smallest tick of time. That's why I think foundationally we do need to say that time is absolute and ticks at a smallest amount of time, just to set a firm foundation. Now, experimentally, we would have to prove that, but theoretically, if you set that as a boundary, then I think you would have less theories popping up. But because we can't really establish that, then people can say whatever they want, and that's what happens. So, but we are getting close to the top of the hour here. So, does anyone have any other comments in the green room? We see anybody in their hands? So we have Jim here. So Let's have Jim up and see what he's got to say.
Hi.
Yeah, hi. I wanted to point out that the defining EM propagation in the vicinity of the Earth, at least out to the orbit of GPS satellites, is fine to refer that to the ECI. I agree with that entirely. But we have to go further out, and then what happens? So, according to the local ether theory, there's a switch. You're switching. At some point, the sun's gravitational potential becomes dominant over the Earth's, and that becomes the preferred frame for interplanetary propagation. And I think that's also confirmed by space probes. So the local ether theory is not just one reference frame for the universe. It's different reference frames for where the gravitational potential is dominant.
Right.
I'd also like to point out that Professor Su's local ether theory, he derives the dependence of speed with respect to the ECI on his using his local ether theory as an effect on the energy level difference of the transition for the frequency that's used to calibrate atomic clocks, and it comes out with the same gamma factor using a quantum quantum-like formula that includes gravitational potential and electric potential. In other words, yes, it's a change of the frequency of the clock. It's not time dilation. And it's the same for the gravitational potential effect on atomic clocks in orbit. And he derives that too. So yes, there's no time dilation, but there is an effect of gravitational potential and velocity with respect to the ECI on the clock rate.
All right. Well, thank you very much, Jim. So, Roger, we are heading towards the end of the hour here. Why don't you go ahead and summarize?
Yeah. So summary is as per the video I'm showing you, that dialect is pointing out that there's been lots of changes being made to relativity, and it's really not having been presented with a definitive theory, and it keeps having it has gaps in the theory, and these physicists like Sabine are adding their own ideas to try to fill in those gaps. The example we've given, she came up with this idea of pseudo time dilation, which is not anything that seems to have been talked about before her. So she's come up with this idea, and she's filling in the gaps by adding this idea to it. So these physicists are trying to make sense of something which doesn't really seem to make sense, and they're trying to impose their own theorizing onto relativity and still call it Einstein's relativity. And really it's just their version of relativity, and with not admitting that they're having this problem, it's then creating problems with understanding relativity. Really, you should be admitting that even if you accept the mathematical formulation as valid, and people like Harry are not accepting the mathematical formulation, even if you accept the mathematical formulation as valid, you should then be saying there's different interpretations as to what that mathematics means. And so you've got all this mess being created in relativity because it's not a definitive theory. It's just an ongoing process of adding and changing things. Thank you.